Today's session is Mechanical Systems and Emergency Power. I'd like to introduce our guests, our speakers. To my immediate left is Ed Perez. His career reflects over 30 years of extensive commercial, institutional, and industrial experience ranging from low-rise to high-rise, small to large, state-of-the-art energy efficiency design. He is responsible for all aspects of M&E engineering, design and specifications to constructions review, project management, such designs have included universities, fire halls, industrial buildings, hospitals, high-rise rental and condominium buildings, and hotel complexes. In addition, new designs and high-efficiency chillers and boiler replacements. To Ed's left is Stephen Jenner, Technical Sales and Construction Manager at Simcoe. Stephen Jenner started his career with a passion for working with specializing heating, air conditioning, ventilation, and refrigeration equipment, working effectively with property managers, consultants, board of directors, and realty advisors, dealing with boilers, booster pumps, chillers, and cooling towers, and fluid cooling towers has led to recognition in this field. Stephen has worked with Simcoe design buildings, installed large-scale projects valuing in the millions of dollars, and has saved owners thousands of dollars per year in operating costs due to boosts and efficiencies. And to Stephen's left is Bassem Sakur, and he's a principal at M&E Engineering with more than 15 years experience in building services, HVAC, plumbing, and energy generators. Bassem is involved in emergency power upgrades projects that include generator replacement, diesel fuel upgrades, underground storage tanks, replacement code compliance, his words, etc. And lastly, at the end is Ken Blasey. He's the Power Solution Consultant for Total Power Limited. Ken is a Power Solution Consultant and is presently Vice Chair of the CSAA C282 Technical Committee for Emergency Electrical Power Supply for Building Standards for Canada, and is an active voting member of CSAA Z32 Technical Subcommittee for Essential Electrical Systems for Healthcare Standards for Canada. Ken has extensive experience in the generator market in Canada with Generac, Baldor, Kohler, and Onan Cummings brands, as well as custom manufacturing of gensets with Peel engines. Ken has managed municipal projects for Toronto Zoo, Aviva Canada, Brampton Transit, Deutsche Bank, Home Hardware Distributor Centers, Toronto District Catholic School Boards, D&D, DSS, and Sick Kids Hospital, MOE, MGS, and many others. Congratulations, Ken. You certainly do a lot.
It just means I'm old.
I believe that's seasoned, since we're all getting old here.
Okay.
We're going to go through this starting with boilers and chillers. And Ed and Stephen are going to speak to that, and then we'll move on to energy generators. We'd like to have the questions held till the end. We have a lot of material to cover, and we'll also have a slideshow at the same time. So without any further ado, Ed.
Thanks, Mark. It's a nice small group, so we'll get through all our stuff. If you have any questions, I think we're going to hold off to the end.
Yeah.
But we'll get going on it. We're going to start off with a term, life expectancy and efficiency. Life expectancy is always thrown around, and as owners and operators and managers of buildings, you're shorter? I'm not tall. As you've all heard life expectancy, and I just wanted to go through what that really means. I believe even one of the speakers this morning said 25 years is a big number in our industry that things start to break down. 25 years is a life expectancy number. What does that mean? It means that 50% of the equipment won't make it to 25 years, and 50% will make it beyond. So what I just wanted to make a note of here is if you get a report and it says, oh, it'll last another 5 years to its life expectancy, that just means half the equipment might make it to that life expectancy. Also, energy efficiency. As it starts to approach that life expectancy of 25 years or 30 years, efficiency starts to really depreciate. Usually in boilers, after about 20 years, energy efficiency starts to go down. So replacement has to be on life expectancy, but also energy efficiency, and then also reliability. You have a lot of people living in your buildings, and going without heat in Toronto, or if you're in Winnipeg, even worse, is probably going to cost you an awful lot more than replacing a boiler earlier. So what we're going to do is, there we go, talk about frequency drives because they're part of the chillers and part of the boilers. In the old days, we used to go, oh, frequency drives, yeah, if you had a big fan, big motors, you could put a frequency drive and save energy. Nowadays, we can get good efficiencies, good paybacks on even 5 horsepower motors. So when you look at your plant and you see a 20 horsepower, 15 horsepower pump pumping chilled water, hot water, it might be an opportunity to save energy by putting in a frequency drive. It also helps in having the motors last longer due to the fact that it has a soft start, and you might get better comfort because you can control the water flows better, you can control the temperatures to the system. Has a slow turnover here. Boilers. There has been, over the last number of years, an influx of high-efficiency boilers and condensing boilers. So I want to touch on that subject just a little bit. It's not new technology. This technology has been in Europe for 25, 30 years. We're late, very late getting into the game, but it's out. Be very careful, though, on what people try to say. Oh, you should have a high efficiency, a condensing boiler, really high efficiency, you can get 95%. Understand where that efficiency comes from. In order to get above even 87%, you have to have condensing boilers. In order to have condensing boilers, what you have to have is you have to have a system that can use low temperature water. So if you had a building with fan coil units, you can use low temperature water, 100 degrees, 120 degrees to heat. A condensing boiler is a very, very energy efficient way of getting it. You'll get even up to 95% or higher by going condensing. But if you have a conventional rental building with the hydronic heating, you're going to need 160, possibly even more, 160 to 180 degree water in that perimeter. Condensing boilers will not condense if you're supplying 160 or 180 degrees. Therefore, just go to a high efficiency boiler that will get you in the 85 to 87% energy efficiency rate. You want to do that because condensing boilers are expensive. So you want to get your best bang for your dollar, and that means that if you can use low water temperature, i.e. around the 120 degrees, 100 degree range, you spend it to get the condensing. But if you don't, if you have hydronic heating, then just go for the high efficiency one, and that will get you your best return. I said 25 years. 25 years, again, is a number that everyone likes to throw out. If you have a domestic boiler, a lot of times that life expectancy drops to 20 years. If you have a heating boiler system that is at around 160 degrees, you might get 30 years out of your boilers. Some of the big boilers might even get 35. But again, be careful. These boilers that were put in 30 years ago started with maybe an 80% efficiency. When it starts to hit 25 years, you're lucky to get 60, 65%. So now you're going from a 65% boiler to an 85% efficient boiler. That's 20% savings on your gas. That could easily be paid back if you say, installed a new boiler at 20 years, you would get that payback within that 5 years, and you wouldn't have the problems with having an old boiler. So you get reliability, reduced maintenance. Obviously, if you change your boilers up front, you get a reduced maintenance cost. The whole trick then again is when you go to replace your boilers, don't just look at your boilers. We talked earlier about pumps, but it's also the piping in it. So be careful about there's a lot of people out there that will just go out and say, oh, I can replace that boiler for you for X amount of dollars. They just go and just swap the boiler in and out. And all of a sudden, we get called in because it doesn't work. Okay, the new boilers, what you also have to do in order to get your 85% is repipe it. Not totally. Like, we're not talking about ripping out your boiler room and redoing it, but there could be problems with your primary and secondary loop. You don't have one. You just have one big primary loop. So it would be good to design primary, secondary loop. Controls. Controls used to be, again, just like the frequency drives, very expensive. Nowadays, you can get really good small controllers for boilers. A lot of the high-end boilers come with their own control systems, so you're going to get better efficiency and better comfort because you can control your heating better. You're going to have to replace it, so that's where Steve comes in, if I'm not mistaken, and how to go about replacing it.
Yes. So I wanted to talk a bit about the logistics of the construction as far as replacements of, I guess we'll start with boilers. So typically, boiler projects are relatively more simple than chiller projects because boilers are usually, a lot of them are stock equipment. They're waiting somewhere to be installed. So you could get a boiler in 2 to 3 weeks if you really needed one. When it comes to domestic hot water systems, usually you're looking at about, depending on the situation, a 12-hour shutdown will get the new equipment installed and get it back online so that you can't have your building without hot water for too much longer than 12 hours. Otherwise, you're going to have a lot of trouble. Startups of good quality boilers are usually done by the manufacturer the first time. So these are things that have to be scheduled prior. Usually with boilers, another big thing to keep in mind is usually a boiler plant is in a basement or it's on a roof, and you can usually move boilers through the elevator. You don't have to get into cranes most times. If they're underground, they can go through the parking garage, or if they're very large, you could even get into a knockdown boiler that's actually built on site. So that's pretty much for boilers.
Sure. We'll move on to chillers quickly. This is the more exciting part. We covered off boilers because of the sort of the high efficiency and condensing stuff, but chillers, I've been around, as my bio said, way too long. I think longer than Mark even.
No carbonate.
Yeah, you're going to have to do it to me. So when I was around, and for the last 25, 30 years, a chiller was a chiller was a chiller, and if it worked, you left it there because it worked at about 0.75 to 0.85 kilowatts per ton. And that, just remember the number. It's an efficiency number. The technology almost stayed the same. The Trane Central Vac, probably if you have a chiller in your building, that's what you got, a Trane Central Vac or a Carrier. They're workhorses. They just lasted forever. Technology over the last 5-6 years has really caught up with chiller manufacturers. We started off with variable speed drives, frequency drives, just like now we can put them down to 5 horsepower. We can also put them up to 500 horsepower on a chiller. Really improved the efficiencies. We got about 30-40% efficiency out of that. Just lately, in the last 5 years, they've come up with the bearingless, oilless chiller, which is as an engineer, as a nerd, it's cool. Basically, you have a very large motor, very large compressor that floats on a magnetic field. So you have no more oil, no more bearings, no more problems with oil migrating into the chiller, which is a huge problem with efficiency. And it's all floating on about 1 or 2 millimeters of a magnetic field. So the friction loss is incredibly little. What happens then is that your efficiency drops down to 0.35, 0.4. So it's half of what it was years ago. The technology, or the way it looks, is the same. The internals are very different. Again, there's no oil in this chiller. The control panel on there, I remember when I started off in the industry, I'd walk up and there'd be knobs and dials and switches and everything else, and I'd walk up with a chiller mechanic and I'd put my hands in my pocket, because if you ever touched one of the switches, you'd blow up a chiller. With the control panels now, I can operate a chiller, you can operate a chiller. It's all computer controlled. If you try to turn on a chiller and the chiller doesn't want to turn on, it won't. If it doesn't sense that there's flow, it won't turn on. It becomes very energy efficient, because it can control its frequency drive, it knows its chilled water temperatures. So here we go back to that energy or that life expectancy. Again, chillers do have a life expectancy of 25 to 30 years. What we're recommending our clients do now is take a look at the energy efficiency of it and say, well, we could actually replace the chiller at 20 years, get that energy efficiency, because now you're going to use half your electrical cost. Half is a lot, okay? You know, in boilers, we get very excited about, we get very excited about boilers when we can save another 5%, 7%. In chillers nowadays, we can save half of the hydro. So that becomes a very big thing in that instead of changing it in 25, 30 years, you have to look at the economics of it and then possibly change it in 20 or 22 years if the economics show that you can do it. We have new technology. So many people out there just think that the chiller is the chiller, and it's not today. So we have some good things in energy efficiencies. There's different types of chillers too. Back again, 20, 30 years ago, it was predominantly the centrifugal chiller. That's one there. It's sort of the classic. It is still the classic in the Toronto area, but there are scroll chillers and screw chillers. Each one has its own application for its own buildings. Hard to go into right now, but each one has a plus and a minus. Some might be easier to put in, physically smaller. Some are a little louder, especially the screw chillers. You have to be a little bit careful with that.
Less than 5.
Less than 5. I think we're good. What we're going to talk about now, to go back to boilers, there are incentives for saving energy on boilers. There are incentives to save on the hydro for here. So again, once you're thinking of changing boilers, once you're thinking of changing chillers, think incentives. There is incentives from Enbridge, incentives from Toronto Hydro, OPG. There's a lot of places to receive money. You're not going to get the whole installation paid for, but you get money for it, which is better than nothing. We'll talk about some installations.
So from a construction point of view, when it comes to chillers and cooling towers, I think the biggest thing from my side of the business is if you're looking to replace your chilled water plant, you should be starting working with Ed by the fall of the year before. Chillers, they're 12 to 14 week lead times. They have to be purchased, otherwise they will not make it to the site in time. And from my point of view, usually what happens is we end up getting a chiller delivered to site the first week of April, and it becomes an absolute nightmare to complete that job and have that chiller running before the first hot day of the year when everybody starts screaming. So that would probably be the most important part of dealing with that type of thing. And I'd also just like to say that because I'm on the contractor side of things and Ed is obviously on the engineering side of things, I would caution you that when you interview or whatever your process may be when selecting an engineer, you be very careful which engineer you choose, because I've seen other engineers out there and it's very scary what they will actually, if you even want to call it, design you and advise you to put in. I'm not trying to pump up Ed here, but I've done a lot of projects with Ed and his team, and they've all been very energy efficient, high-end projects.
Well, I think we might run over by 1 minute, but we're going to get into just 2 seconds of the cooling tower. It's the sister piece of equipment to the chiller. Don't forget about it. It also dies in 25 to 30 years. The good and bad part about the cooling tower is you can decide to retrofit it. And again, talk to your engineer. Try to figure out what's the most energy efficient on it, depending what you have. If you have the oldest type style, which is the wood ones, you can rebuild it forever. Eventually, though, you get that reliability thing. kicking in. So, you know, just because you have an old cooling tower and you can keep fixing it and fixing it and fixing it, reliability comes into play. There is some increase in efficiencies. Unfortunately, I can't stand up here and say they've invented a new way to cool water, but they have gotten more energy efficient. They're more reliable. The motors have all frequency drives on it. The fill in it is a little bit better, so we lose less water, which is good for the environment. But again, just don't forget about it. So many times we'll get calls from clients and they'll say, oh, you know, my chiller's getting old, I really need to replace it. And I say, what about your cooling tower? And I get that glazed look in their face. I have a cooling tower? Yeah, the big box on the roof connected to the chiller. So please, in your capital plans, make sure that you understand that you got to look after the sister. And then as far as install?
Cooling towers, generally 8-week delivery. Craning is obviously a concern with any cooling tower, depending on the height of the building, where it is, if you have a parking garage, etc. They can be built on site. This year we did quite a few cooling towers that were actually delivered in pieces. We rigged them to the roof in pieces and then we built them. Yeah, just to go on what Ed said, don't ever ignore your cooling tower, because if you don't have a good working, efficient cooling tower, your chiller is no good to you. So.
We just did, I'm Jan with Synergy Mechanical, and we just did one of these, exactly what you're talking about. So somebody put in a beautiful York chiller, and their cooling tower, they can only run the chiller at 41%, I think.
That's a good cooling tower.
Okay, so if you don't really look at your tower at the same time, you're going to have this super sexy chiller there that you're so excited about, and the tower won't keep up with it. So always, like, you go to a doctor, get a second opinion from somebody. If someone says, just do the chiller, don't worry about the tower, you probably want a second opinion. Just have somebody go in and take a look at how the two are functioning together. Look at the new technology you're going to be putting in, and then really do a hot run around the cooling tower. Because they do work in tandem, and you can have this great chiller that you can't boot up to its kind of full capacity.
Beautiful. We're going to jump to the next topic because we're running a little over. It's on energy generators. Emergency generators, my apology. And Basson is going to talk about the code changes, and Ken will cover the installations.
Good morning. My name is Bassam, and I'm from M&E Engineering. Unfortunately, there is no rebates for emergency generator. This is a code requirement, and you have to keep it in good order in order to work. It's a life and safety system. So I think everybody is familiar with the Ontario regulation established in 2001. What this code is really about is maintaining the generator as per CSAA B139. So what do you need to know? Originally, the regulation called for all diesel installation, all diesel appliances have to be inspected by the fuel distributors to see if there's any deficiency that you have to be aware of so that you can rectify it. Now, because of the sheer volume of the amount of installations, they put it into a certain period of time, starting from 2002 and ending in 2007. By 2007, all diesel installations should have been through a full, comprehensive inspection by the fuel distributors. But again, by 2007, we're still seeing systems nowadays that haven't been inspected and haven't been reviewed by the fuel distributor. So what we're looking for is basically TSSA is the governing body that look after the implementation of the code, the safety system. It's like the elevators, but it's, there's a separate division that goes after the boilers, separate division goes after the theme parks, and separate division that goes after the diesel code. So what are we looking for? Basically, when you have a generator, you have three main systems. You have your diesel fuel system, which represents the tanks, the piping, the accessories like the filters, the valves, the anti-siphon valves. And you have the exhaust stack, exhaust muffler, and then you would have your ventilation system, which is represented by the dampers. So going back to the fuel system, if you look at the tanks, so you have different type of tanks. You have single wall, double bottom tanks. But in any occasion, the code now is coming to a change. Single wall tanks will not be allowed for a new installation. So everything will go to double wall. As far as the stack, nowadays we're looking at having, the code calls for a double wall stainless steel exhaust because it's an approved venting system. But for, I would say, 90% of the generators installed in Ontario, they all have the Schedule 40 black steel, which is not a problem, but it's not an approved venting system. So what you have to do now is you have to go through the safety measures that the SSA are requesting in order to maintain this Schedule 40. That's why sometimes you have to do temperature tests, sometimes you have to do a CO test, pressure test the stack to see for leaks. You have to make sure that the penetration through the wall or through the ceiling have the adequate clearance from combustibles. As far as the dampers are part of the ventilation system. So you will have an intake louver to get the fresh air in, you have an exhaust louver to get the hot air out, and then you have your circulating dampers. On the fresh air damper, you need to have a spring-loaded actuator. So in case of a power failure, the damper automatically springs open. It allows fresh air to come in, and when the generator starts, you already have, your combustion doesn't have any issue with that. So, and TSSA, as an added safety, have added an alarm. So if the damper didn't open, this alarm have to go somewhere, have to notify either an operator or through the fire alarm panel, or maybe just a panel at the security desk where somebody can recognize that there is an issue there and you have to look into it. So if we're talking about the tanks and where can we put in the tanks, tanks can be installed outside, inside, on the ground floor. Capacities varies from 50 liters, and I've seen installations inside buildings up to 20,000 liters. Now, how safe it is? Again, it is allowed by the Ontario Fire Code to have a large size of diesel storage, provided that you have the proper containment for it, proper fire suppression. The type of tanks, each type of tank have different ratings. Some of them are rated to ULC S601, S602. Each tank has its own requirement. And if you have a single wall tank, you have to make sure that you have a containment underneath in case of a spill. You are able to catch it right before it goes out of proportion. Now, for elevated installation, sometimes you have your generator on the roof. You're going to have a main tank in the basement, and you have your day tank on the roof. So you're going to have a fuel pump system that transfers the oil from the basement all the way up to the top. And also for fuel pumps, you would have some pressure sensing devices. In case there is a leak in the piping, the pressure sensing device will shut off automatically the pump and prevent the entire amount of fuel in the tank to be spilled out. Okay, for exhaust stack, we already discussed that. Now what TSSA is trying to do is apply NFPA 211 for diesel exhaust stacks. In principle, the CSA B139 does not discuss or go after the stacks. So they've referred to NFPA 211. NFPA 211 dictates where the stack terminates, how much the temperature of the stack should be, how much clears to combustibles. So if you have a generator that have a high temperature over 1,000 degrees, it's called the medium heat appliance. Less than 1,000 degrees, it's called the low heat appliance. The majority of the installations for diesel stacks, for diesel generators in Toronto are considered to be low heat appliance. But natural gas generators usually have a higher temperature. They're within the medium heat appliance temperature range. And the other item is the clearance to combustibles. A lot of time you go up on the roof and you see that the stack goes out through a pitch pocket. You have probably few inches from combustibles, and that have led to several fires. The code requires at least 18 inches from combustibles, which you don't see in most of the installations. All what you see is just a cone and sealing around the pitch pocket. Same thing for dampers. Nowadays, it has to be a fail-safe open within 15 seconds. An alarm signal is required, and it should be monitored by an operator. Now, our preference is to go after the fire alarm panel, where you have your generators monitored there. But most cases, the fire alarm panel is out of date and doesn't have adequate zones to put in the damper actuator. But we've managed to put in the alarm panels in a place where somebody can hear it or somebody can see it and advise the building tech. So the diesel fuel components, part of the tank system, you have your piping, valves. Everything has to be ULC, with the exception of the piping. So let's say if you have a fire valve, the fire valve has to be a ULC rated. And in the market, there is no ULC valves up till now. And until recently, they've introduced one type of valve that have a ULC rating, but it's only ½ inch. So anytime you want to install diesel fuel accessories that's not ULC, you have to apply for a variance with TSSA. And after you apply for the variance, they will come in and inspect it and provide you with a letter saying that it has been done properly. So majority of installation would require a variance. Anytime you have a deviation from the code, you would require a variance. Some of the items would require a stamped letter from an engineer, especially the exhaust stack, because of the safety issues associated with it. So you will have some contractors coming into the building, oh, we will do the diesel fuel upgrade, and you don't need an engineer. In fact, you do, because every time you have to certify the stack, you need a letter stamped and signed by an engineer. And that's why we have some issue with the property management. So, well, I can do it without an engineer, and they will guarantee that it will pass the SSA. You know what? It will not, because they're going to ask for a letter signed and stamped. But again, you don't have the authority over property managers to convince them, but it happens. So after the whole thing has been completed and designed and sent to TSSA, they will send an inspector to see the system in operation. They want to test every single thing. Sometimes they ask to witness the temperature test. Sometimes they want to test the pumps. So keep in mind that at the end of the day, and before you complete the system, TSSA have to come and inspect it, and they will provide you with a letter saying that, yep, it has been done, it has been completed. So what do you need to do? Don't panic. If your fuel distributor told you that you're not allowed to have any more fuel in the tanks, you will still have some time to get a fill, or you can arrange for a one-time temporary fill through TSSA, provided that you have applied for variance and you have been proactive and looking after the deficiencies. And it's not a complicated thing. It's a lengthy thing. It may take some time, but at the end of the day, the idea is if you meet the requirement, you should be okay. It's costly, but it's not something out of the ordinary. And again, I will leave the questions till the end. If anybody has any question, please let me know. Thank you.
Thank you, Bassem. Here's your. Thank you for allowing us not to panic. And now Ken will help address the installation. Thank you, Ken.
Yeah. All right. Thanks very much. I'm going to talk to you a bit today about installations. Bassem's touched on all the key points that you have to really be concerned with if you have a problem. But when you have a system, there are a lot of things that need to be done on an ongoing basis, not only in order to comply with code requirements, but to ensure the the life expectancy that Ed was talking about earlier, because it applies to generators as well. So I'm going to go through some items here, and again, if you have any questions, we'll answer them at the end. The emergency generators are mandated by the building code according to the size and type of occupancy of the building, and the CSA standard that controls how the system is designed and installed is C282. The latest edition of which came out this April. It's 2015 edition. It's available for sale, and the engineers, of course, work with the latest code that's been adopted by the building code. So I believe we're on 09 right now with the current building code. Hopefully in the very near future, the 2015 edition will be adopted as well.
Still 06 on the fuel code.
Yeah, you're still on 06 on the fuel side. One of the things we did, just to give you a little bit of history on that, as briefly as I can, CSA has a cycle for each of the standards that they produce, whether they're standards that have to be adopted or a code like the fuel installation code. And as of 2000, they changed the cycle for all of those documents to be 5 years. Well, that was fine, but they were still not synchronized. So every 5 years, something was done to issue a new document every year on that 5-year cycle. Starting in 2009, we started to recognize the fact that these standards need to be synchronized because they refer back and forth to each other. C282 refers to Z32 for healthcare facilities. It also refers to B139 for diesel sets and for B149 for gas and propane sets. So there was a need to synchronize these documents and harmonize them so that we weren't referring to stuff that was out of date in another publication. So as of 2015, the 4 documents that I've mentioned have all been harmonized. And for once and for all, hopefully, we can get away from the finger pointing, oh, well, that one says I do this and this one says I do that. And then the inspectors don't go crazy trying to figure out which one is more important. So going forward, I think you'll have a more standardized approach to how to regulate the systems that you have in place. 282 dictates requirements for the equipment, how it gets installed, and also how it gets maintained. Okay, maintaining it starts with the initial commissioning and goes on and on for the life of the unit. As far as diesels are concerned, the trend is to move away from diesels now because of the expense required in maintaining the fuel systems. But for many, many years, diesels were the only allowed system because you had to have fuel storage on site. Different parts of Canada react differently according to the geography of the area, like in BC, seismic zones, for example, and even in Ottawa, they're not too fussy about having natural gas emergency equipment. But in Toronto, it's pretty well accepted that you can go either way. But you have to have somehow a reliable fuel source, and if you're going with a liquid source like diesel, then it has to be a minimum of 2 hours supply, so that the purpose of the standard is to evacuate the building in case of an emergency. So you got 2 hours to get everybody out of the building, and that's what the generator is there for. As a result of that, the generator doesn't see many hours of use over the course of its life expectancy. I've seen generators that are 40 years old that only have less than 100 hours on them. Part of that is because they weren't maintained properly and tested regularly, but the other reason is the call for duty doesn't come very often, as you all know. Okay? So if you're having an on-site fuel supply, of course, then there's another standard that you must be in compliance with. But on a regular basis, there's a whole list of things that have to be done on a regular basis at different intervals over the course of the life of the unit to keep it working as reliably as possible. There's no point in having an emergency generator if you have an emergency and it doesn't work. Okay? That also affects your liability insurance with your insurance carriers. These days, risk is a huge topic with insurance companies, and if you don't have the records to substantiate that you've maintained the equipment properly, you risk paying higher premiums. especially if you have an event at the building and the fire department records it as an event that the generator didn't work, okay? So it's a very important thing that the maintenance be done and it be recorded properly. This is a list of the stuff that has to be done on a weekly basis. These items are performed by the operators or maintenance personnel in the building. We train them how to do that when we have the commissioning services go to the site initially. And we also provide on an ongoing basis training seminars at free of charge for all of our customers, so they can send people to our office and just get refreshed on how to do this, or even learn if they've never seen one before. All right, but that's quite an extensive list just on a weekly basis. Then you have monthly inspections on things that don't require as much monitoring, and testing. One of the important parts here is that on a monthly basis you operate the system under load for 60 minutes. Now, diesel engines are more susceptible to problems if you don't have 30% load. They start doing what's called wet stacking, and they make a mess all over the outside of the engine block. So the code requires that you have at least 30% load available, which in most cases, if the engineers have done their job properly in designing the system, you're going to have at least that minimum amount of load to test the system when the testing is done. Okay, but that 60 minutes exercises the engine. All right, it also gives you an opportunity to find out if there's anything wrong with the system, because you're heating up the engine, you're operating it not maybe at full temperature, but at a high enough temperature that you can see where problems are going to start to exist, and do something about them before it becomes a real panic situation. Operating the system under load means that all the transfer switches have to operate. So you will have interruptions, tiny though they may be, in your power to your building loads, okay? And this is not the whole building, it's just the emergency loads, your elevators, the fire pump, which is sitting there stagnant anyway at the time, but all the emergency lighting will experience a flicker when the transfer switches operate, okay? That's normal. People complain about it, but really it's not even worth complaining about, because it only takes less than a second to occur in each case. But if you don't operate the transfer switches, you're not testing the whole system. Okay, and you can say, well, my emergency generator started, but we still didn't have power because the transfer switch didn't work. Well, that's great. So it's the point of the weakest link in the chain that you have to worry about. And if you don't test the whole system, you don't test all the links in the chain. Okay, we're getting, okay, I'll go quicker through this. Semi-annual inspections have to be done. There's a bunch of things there. Then, I know, but there are a lot of things. These are all listed in the C-282 document if you want to purchase it and have it on file. Annually, you have to do, among other things, a 2-hour load bank test, which is done at the full load rating of the system, okay? That exercises the engine at its maximum temperatures that it's going to see. All right, and it gives our technicians a chance to monitor the whole system throughout that 2-hour test to see if anything's going wrong, okay? We do an infrared survey as well while the test is going on to see if there's any hot spots due to poor electrical connections, all right? And over time, things have a way of managing to work themselves loose sometimes because of heating and contracting as the cables heat up and cool off when loads come on and off over time. So, you know, it's very important that all the electrical connections be monitored. That's starting at the generator circuit breaker all the way to the transfer switches, okay? So that infrared survey is very important, but each one of these inspection periods includes all the stuff from the other periods, okay? So in other words, the monthly test includes all the weekly inspections because it's done on one of those weeks in the month. Same with the semi-annual and the annual. So the annual inspection takes quite a long time because you have to go through all the stuff that you would do every week, month, and 6-month period as well, okay? And then there's a list of it, all the stuff there. It's quite extensive. Again, these are what load banks look like. The top one there in the picture is a 1200 kilowatt load bank, so we use that on the larger sets. And on the smaller ones, you see 3 of the 100 kilowatt. They're quite actually portable, so they can be taken up to the roof, which is where I think this picture was taken, on somebody's roof. But the cabling is quite a job sometimes, depending on where the generator is compared to where we can put these things outside. They generate a lot of heat. They're giant toasters, okay? So you can't have the heat going back into the building. The infrared survey, again, just to give you a pictorial idea. A handgun, thermal handgun is used to perform this. It's very quick. And we can go over a number of electrical connections in a short space of time. Fuel storage, okay. The fuel must pass an annual test. We extract a sample from the bottom of the tank, farthest away from the fill port if possible. So that's the worst possible sample we could get out of your tank. And we take a look at it. And if we can't see through it like this glass of water, you have a problem. Diesel fuel is susceptible to bacterial growth, and if there is water from condensation mixed in with the fuel, it supports the bacterial growth even more, okay, and promotes it. And you get, the one on the left there is probably the worst case example of what you might see coming out of the bottom of a fuel tank, okay? So that can cause problems all through your fuel system, besides the fact that it doesn't comply. So on an annual basis, we take a sample, and if you have dirty fuel, we will give you an estimate to clean the fuel by pumping it out and filtering it and putting it back in the tank over the course of maybe 2 or 3 or 4 hours, depending on how long it takes to do that much fuel. And as I was alluding to earlier, every 5 years we have to do another set of inspections, which is more invasive, if you like, into the system. Megger testing the generator windings, which means we have to disconnect them from anything else outside the generator machine and put a high voltage on them to see whether the insulation of the windings is breaking down. Replace thermostats, adjust valve clearances, and flush the cooling system. I'm just going to go to the next one. Now, as of the 2015 edition, we have to do infrared thermal imaging. So before we were coming with a heat gun and taking quick measurements to see if there was any alleged hotspots. Now we have to take a picture with a thermal imaging camera every 5 years, okay? So that's a more extensive and invasive approach, but it gives you a picture record of what was seen at the time of the inspection. And when the fire department comes in to check your records, you can show them all these pictures. They are to be stored with the rest of the reports. There's a lot of other stuff that has changed, may not directly affect maintenance in that sense, but how the system gets designed is definitely something that's going to be involved with the changes. And that's all I have at this time. I spend most of my time advising engineers on installation requirements for generators that we sell and educating them on, you know, how to design systems with generators properly. We've spent some time with these fine gentlemen here on many projects over the past 10 or 15 years. We're quite happy to work with them, and I appreciate them asking me to come today. Thank you very much.
Thank you, Ken. We are at the portion now where we're opening up questions from the audience to our panel. We went through a lot of information because there is a lot of information, but we also want to leave as much time as possible to engage you. If you could, maybe even within your question, give a little bit of background, size, the building, the issue, things of that nature. So, yes, sir.
This is for emergency generator. You mentioned 2 hours mandatory for
you're using on-site storage, you have to have 2 hours of fuel stored on-site, minimum.
What about connecting the gas, the natural gas?
Okay, the changes that were made to the standard in 2005 allowed for the use of natural gas as an off-site supply, where it's allowed by the authorities, of course. But in order to guarantee that the generator gets that fuel during the emergency, it must be provided with a dedicated pipe coming directly from the meter station outside the building. Okay?
But the number of hours.
Well, the natural gas infrastructure is basically an infinite supply.
So we can be.
Right. But as long as the authorities have approved the use of the natural gas for that site, then you have no worries. As long as you have that dedicated pipe, which is monitored as well by the generator controller.
So
Okay.
it also depends on if the generator
Could you pull
is, sorry, if the generator is considered as life and safety, usually you coordinate with your gas utility to have an uninterrupted supply of natural gas. You pay a premium for that, but usually if it is specified as life safety, then you should get involved with the utility to provide you with this service.
For monthly residential, we bring it from just beside the meter from outside.
How old is the building?
40 years old.
4?
14.
40. So your chances of having a dedicated line is no, zero.
We just need
Oh, you just did the renovation then,
a new generator.
and you have a dedicated line?
Yes.
Then you should have no problem with the
As long as your gas supply is uninterrupted,
uninterrupted, yeah.
Uninterrupted.
uninterrupted gas supply.
But if there is a storage, it's only 2 hours. We are mandated to
Yep.
provide.
Oh, so you
A
have
lot
some.
of, a lot of times, what engineers will do, though, is at least give you 8 to 16 hours of storage. One, so you're not constantly filling it up, and two, in case of emergency power outages, so that will run a little longer than 2 hours. Because if you're testing it weekly, you're going to really, you need a little extra than the 2 hours.
I can add a little bit to that. In concert with Enbridge, I found out several years ago that there were about 25 sites in Ontario where natural gas on-site storage is actually used for an emergency generator. It's very expensive, and basically it's designed for your 2-hour supply. You have gas bottles that are recharged from the system after they get used up, okay? But typically, to have natural gas storage on-site costs you about an extra $50,000 to install it, because the gas is stored at high pressure, up to 3,000 psi, I believe, and the equipment to do that is very expensive. And when the natural gas is turned back onto the building after whatever caused the outage, there's a compressor there to recharge the bottles. But one by one, because the authorities now see that the natural gas off-site supply is allowed, these original installations are being removed.
Well, also, too, you have to check with your insurance company if they'll even allow you. Most insurance companies nowadays in high-rise residential won't allow you to store natural gas.
That's a good point.
From my understanding right now, the term life safety or emergency generator or a standby generator, the wording is very, very important.
Very much so, because once you fall under emergency generator, then you have to fall under all the codes. A standby power doesn't have to follow, it still has to follow all the safety regulations for fuel, but it doesn't have to have all the checks and balances that Ken was talking about.
Right.
What's the difference between the two?
Physically, nothing.
Definition.
In definition, one is running, the emergency power is running your emergency lights, it's running your fire alarm systems, it's running your fire pumps. So it's running the life safety of the building.
Standby power.
Standby power is just a convenience.
It's going to run emergency lighting on it.
It'll run emergency lighting, it will run elevators, It will run all sorts of things, but it's not required by the OBC. It's not required by code. It's a convenience to your tenants.
An emergency generator can have non-life safety loads added to it, but it still must comply with all the requirements of C-282 and the fire code, etc., if it has life safety loads, depending upon it.
We actually highly recommend it. That most generators are loaded to about 60% with life safety stuff, and then we recommend other things to be added to the generator, as simple things as the garage door opener. You know, you have a power outage and you can't get your car in and out. But to other sort of more useful things, for instance, like the makeup air units for the corridors, so that in the middle of wintertime the corridors can stay warm and infiltrate warm air into the suites and keep some comfort in the building and protect the building from freezing.
Water
So
booster
there's-
pumps.
Yeah, there's water booster pumps too, so that even if you're on the 20th floor, you get water.
It's important to flush your toilet daily. For some people, anyway.
Even after this winter with all the freezing, we're looking at some apartment sites to put in backup for essential systems, not entire systems, but the boiler, for example, keep heat, hot water people, things like that. So it's very specific, and we're just getting into it now with specific sites. So
You have to be careful though. I mean, we've done a lot of studies where we go out and test the generator to see how much spare capacity there is. So depending on what spare capacity there is in your existing generator depends on what additional non-life safety items you can add to it. If you're in the midst of, I have a 30-year-old generator and it's time to be replaced, then your engineer should consider what other additional loads you may want to put on it and then size the generator appropriately if you're going to buy a new one.
Are there any questions for boilers, chillers? Yes.
Just some feedback on the chiller side of Toronto Hydro with regard to incentives. Something that we would encourage, you said earlier, to start planning in September, October. Push that forward to April. Do a base load for that current summer, so the following you've got a measurement that will be compared to maximizing the incentive. Otherwise, you're looking at faceplate value and you rate that at 60% of what the potential incentive could be.
So what he basically says, 100% correct, is there is two incentives. One is we test before and test afterwards, and the other one is we just send pieces of paper to Toronto Hydro saying the old chiller did this and the new chiller can do that. And there's a substantial difference in the incentive amounts that you get. Unfortunately, we get in our office an awful lot of calls in September, and we're into prescriptive measures, which is just faceplate. But if you are even thinking about it to change your chillers, then it would be good to talk to your engineer and get some testing done and monitoring done during the cooling season. You have those numbers. If you decide not to change your chiller, it's not the end of the world. You still have it. If you change it a year later, and Toronto Hydro still have their incentives, they'll probably 6 more years, hopefully. Sorry, I've been in the business too long. I've seen it cancel, but hopefully it's not going anywhere. So get it done sooner rather than later, and then when you just decide to change your chiller, you got it.
Talk to Toronto Hydro first as well, when you're concerned. We can have some advice and support on the technical side as well, towards incentive.
But yeah, I think that's a big one. Don't forget, there is money out there. There's money from Enbridge. There's money from Toronto Hydro. There's money from OPG. There's money from BOMA. I don't think anyone had BOMA buildings here, but
No.
there is money for energy audits. If you do an energy audit on your building, 50% of the energy audit will be paid back through OPGs. Is it through Toronto Hydro too?
It's actually
ISO,
ISO.
yeah. There's more alphabets out there, but bottom line is, if someone charges you X amount for an energy audit that is an ASHRAE 2, you will get half of it back.
And that is a good point that you made. These aren't things that we can put our head in the sand and they'll disappear. You're going to have to address everything that's been talked about, whether you want to or not. Sooner or later, has to be addressed. So first things first, there are incentives, there is money available. Find out what you can on your own. Find out through your engineer. A good engineer is going to list it for you, is going to find it for you. Find out through your suppliers. This is your money, so take advantage of it. Unfortunately, we've come to the end of this. We're actually running a little bit over, but everybody on our panel is available. You can take them aside now or outside, and we'd like to thank everybody for attending, and CFAA would like to thank our panel.
Good luck.
The RHB Insider Network is an RHB Inc. production. Publishers of RHB Magazine and the producers of RHB Newsreel.